In this video, we're going to go ahead and put into play the characteristics that we learned about in the previous video. So we are going to learn how to eliminate options when we are given a quadratic equation or quadratic function and asked to choose the correct graph. We will also talk about it the other way around. So we'll be given a graph and then we choose the correct equation to go with it. So let's talk about how we can use what we learned about the key characteristics of quadratic graphs to answer these multiple choice questions. So we talked a little bit about these five altogether, these five characteristics we can find from an equation. Now, I would suggest this order. You don't necessarily have to follow this order, but this would be my suggestion in terms of the least amount of work to make sure that you get the correct answer. So, and typically the quickest as well. So look at A first to determine if it goes up or down, and we can cross out any options that don't go the correct direction. Then I would look at C to determine the y-intercept. So then you're looking at the multiple choice answers to see, is that going to be the correct graph based on, is the y-intercept correct? Then we look at B, and remember for B, we look at that table essentially looking at if A is positive, if A is negative, if B is positive, or if B is negative, and then also if B is 0. So that's what we look at. And with this, if we have a positive and a positive, the vertex is on the left side. Negative A, positive B, the vertex is on the right side. And then for positive A, negative B, it flips over to the right side. And then negative and negative flips over to the left side. And then remember, if B is 0, either of these, it's going to actually be on the y-axis on both of these examples. So those three would be the three that I would start with, and hopefully that would eliminate all your answer choices. Last case scenario, last case would be these two options, so finding the vertex, and then very, very, very last resort would be finding those intercepts, those x-intercepts. All right, so let's try some examples and see what we can do. So example 1, we first want to find our A, B, and C when it's a quadratic equation in standard form. So our A is going to be 1, the number in front of x squared, B is 2, the number in front of the x, and then our C is the constant, which is negative 8. So first things first, determine if it opens up or down. So because A is positive, this is going to open up, which means I can rule out option B. So B is not going to be the answer because that opens down. Then move on and look at, I personally would look at C because I find that easier. And if it eliminates all the options but the correct one, then you don't even have to worry about this chart on that problem. So on this one, C has to be negative 8. So that means our y-intercept has to be at 0, negative 8. So looking at our remaining choices, that is the correct y-intercept here and here, but the y-intercept here is negative 4. So D can be eliminated as well based on the y-intercept. So now we have two options left. So that's when we would go ahead and refer to that table. So we look at that table and we see we have a positive A and we have a positive B, which means if we have a positive A and B, then our vertex should be on the left side of the y-axis. And if you look at the two remaining answers, the vertex in this one is on the right side of the y-axis here. And so that one, A, is going to be eliminated. And that means if we look at C, the vertex does fall on that left side of the y-axis. So C does give us our correct answer on this one. Now let's do it one more time, just with a slightly different example. So again, we're going to look at this and we're going to see it's quadratic. We're going to determine what A, B, and C are. So A is negative 2 in front of the x squared. B is 0 because there is no x term on its own. And then we have the constant of negative 4. So C is the constant. So A is negative. So if A is negative, then it opens down, which means we can go ahead and cross out option A as an option that is no longer an option. B is going to be 0. We'll come back to that in just a minute. I'm going to look at C, which is negative 4, which tells us that our y-intercept is 0, negative 4. So if you look at our remaining options here, we can see that our y-intercept, where it crosses the y-axis, needs to be -4. So this one is +4, so I actually can cross that out. So B will be crossed out. And then C has a y-intercept at 0, 0, and so that one can get crossed out. And then D has a y-intercept at -4, and so that one would be the correct answer, choice D, because, again, the y-intercept is correct, and the A tells us it's negative, it opens down. Now, I didn't even need to go on to B, but you would notice that B is 0. If B is 0, in that table, that tells us that the vertex has to be on the y-axis. So knowing that, you could have also eliminated C had you chosen to do it in that order. You would have eliminated C, but then you would have had to look at B and D to determine which one had the y-intercept correct. So that is how we can answer those multiple choice questions when we're given an equation, and then we have to choose the graph. Now let's look at it the other way around as well. So if we are given this time a graph and we have to choose one of the correct equations, we're going to really do the same thing. I would look at those first three again, look at A, then C, then B, to kind of match those up, and then last resort would be 4 and 5, but ideally you wouldn't need to use those. So let's take a look then at this one. So first things first, we can look at our A and determine, does it need to be positive or negative based on if it opens up or down. And because our graph opens down, that tells us if it opens down, that A is going to be negative. Now, it doesn't tell us what negative value it is, but A has to be negative. So we can see here that A is 1, -7, -2, and -7. So we can go ahead and cross out A as an option because our A value is not negative in that one. So A is not an option here. Then I would move on to C. C, remember, we look at our y-intercept. Our y-intercept here is 0, 5. So if our y-intercept is 0, 5, then our C value needs to be 5. So that is not -5, that is +5. So that tells us that if we look at our C value, our constant, we can go ahead and eliminate B as an option because that's -5, and we don't want -5, we want +5. So C and D do have the correct y-intercepts, and they both have a negative A value. So far, those two are our options for this graph. Then we want to go ahead and look at our B value. Technically, we're looking at A and B together, so we can look back at that table that we talked about on the previous slide in our previous video. But we want to look at where the vertex falls. So the vertex is on the left side of the y-axis, so it does fall over here. And our A is negative, and we need to figure out what our B needs to be. So if we look back up at the table and we look at where the vertex is on the left side and where A is negative, we see on the left side is either going to be this one or this one. And if A is negative, that means we're looking in this column. So really it's this graph that we are looking at, and that would be a negative B value. So B needs to be negative in the problem we are looking at. So B needs to be negative. And so because B needs to be negative, we look at -4 and +1. So D can be ruled out because it has a positive B value. So C is actually our correct answer on this one. So now let's look at number 2. So we have our parabola opening up. So if it opens up, we know that our A value needs to be positive. So we can kind of use that same order of process of elimination there, starting with A. So if A has to be positive, then we know that we can go ahead and we can rule out any negative A values. So that would be A can be ruled out here because it is a negative A value, but B, C, and D do have positive A values. So we can keep those. Then we move on to C, which remember is your y-intercept. So the y-intercept here is 1, so 0, 1. So that means our C value has to be +1. So if you look at these options, we can see that we can rule out C because that is a negative C value. So it's not going to be that one. Then we look at B and D. So looking at B and D, we do have opposite signs for the B value. So we are going to look at our B value next. So First thing, our vertex is over on the right side of the y-axis, so it's going to be over here somewhere, and our a is positive. So I copied the table down here to make it easier to look at, but if you have this memorized, then you know that if the vertex is on the right side and a is positive, so if we look in this table, vertex on the right side would either be this one or this one, but if we are looking at a positive a value, that means we are looking in this column, and so that would be this graph right here, and that lines up with a negative b value. So if we look at our answer choices, B is going to be our correct answer. D is not, because in this scenario, the B value is positive and it needs to be a negative B value. So our answer on this one is B. So in summary, what you're really doing is you are looking either at the given equation or the given graph, and you're going to start by looking at if the graph opens up or down. And remember, that comes from your A value, your y-intercept comes from your C, and then your vertex location is A and B together. And you're really doing the same thing for the graph. You're just kind of working backwards. So we're looking at A for open up or down, C for the y-intercept, and A and B for the vertex location. So that's what we're doing on these types of problems to help you rule out options. And then remember, we do have some last resort options, finding the vertex coordinates and the x-intercept or intercepts, to help us rule out any further ones beyond those three.